All right, I guess I'm live. Hey, thank you everybody for showing up to my talk. I'm so excited to talk to you all about mutual TLS. Actually, I'm going to talk about mutual TLS the hard way, and also traffic control the hard way, and then I'll jump into how potentially do it much simple way without sidecar. So let's go ahead and get started, because I have a lot to talk about. So a couple of years ago, we decided to build a house. So we purchased a piece of land, and this is actually a picture of my house under construction. It's a nice house, but it took a village to build a house, right? And I'm actually building a house on a very low budget. So what happens when you build a house on a very low budget, you end up hiring a lot of people that's also doing construction for other houses, right? So you kind of co-sharing your project manager, your contractors, your designer, your architect with everybody else within the area, right? So the question comes to is, how do I secure the communications for all the workers who are building my house, and how do I, control some of the traffic if they have a newer version, a replacement coming, a replacement worker coming. So my name is Lin Sang. I'm a head of open source at a small company called Solo.io. How many of you actually know our company? All right, a few of you. Awesome. So I won't introduce our company. So it's based on service mesh, application networking. So I'm very active in CNCF. I'm an Istio maintainer. I'm also on the Istio leadership team. I'm also a CNCF TOC member and also a CNCF ambassador. Wow, that's a mouthful of titles. All right, so I think I touched briefly. In the cloud native world, the problem we're trying to touch on is how do we secure the communications of pods when they need to communicate to each other, when they are deployed into different nodes and different sites, like the workers who is helping me building my house. How do we secure the communication? How do we do traffic control among these application pods? So I'm going to ask you all a couple of simple questions. So how many of you actually travel here with a passport? All right, a few of you, I guess the out-of-country folks, yes, a long way. And how many of you travel here with a driver's license, some type of identification of you? All right, many of you, awesome. And how many of you believe parameter-based security and networking is sufficient where you could potentially have plain text traffic between your client and server running in Kubernetes? No? No one? Everybody is doing mutual TLS? Yes? All right. Let's get started. So passport. In order for us to build a foundation for mutual TLS, I believe there are three key elements into that. The first one is identity, right? The reason why you're holding a passport or you're holding your driver's license is you want to verify you are who truly you are, right? So think about the passport is the cryptographic identity in the cloud-native world. While you come to the post office, actually, I don't know how Germans gets your passport, but in US, we go to post office and we ask for a passport, and you don't just ask for it, you actually need to bring with you your birth certificate and potential driver's license. Basically, you have to prove who you truly are, right, before the government says, yes, you deserve to have a passport. So that's extremely important for anything that's can be built on top. You have to kind of prove who you truly are with authenticated identity. The second most important thing is confidentiality, right? The communication between the pods running in Kubernetes, they need to be encrypted. They need to be secured so that, and what's most important is only the source and destination. The client and the server can understand, can know how to encrypt and know how to decrypt it. The third thing is data integrity, right? As the data transfer over the wire, because your client and server likely running on different nodes and maybe even in different zone and potentially in different region, you want to make sure the data that's been communicated stay unchanged, right? So not attacked by anyone may in the middle or change the data and replace the data. So those are the three fundamental things to build zero trust architecture and mutual TLS. So in a nutshell, how many of you believe you know mutual TLS really well? Raise up your hands. Don't be shy. Okay, a couple of you. Very good. So correct me if I said anything wrong. So mutual TLS, in a very simple way, I find out the easiest way to understand is to think about the three phases. So the first phase is the client and server validate each other. And how do they validate each other? They present their digital certificate, the cryptographic identity that they have. They present to each other, and then they use the private key to double check, do I know this person? They check with the certificate authority without sending the private key over the wire. So that's the first phase. They say, let's say hello to each other. You are truly the client. You are truly the server. And the second phase is client and server agree on how to encrypt the application data that's going to send over the wire. This is extremely important because that way, we can ensure only the client and the server knows how to encrypt and how to decrypt. Remember, we talk about confidentiality. So that's super important for confidentiality. And then the third phase is application data sent encrypted over the wire, which is why you see that catalog icon. With that, let's go ahead and jump into a demo. Just go over the demo environment really quickly. I'm going to talk about a lot of open source projects. So we're going to show an application build using JavaScript. We're going to run in Kubernetes using K3s. We are going to showcase of Istio. We're going to showcase of Prometheus, Kayali, which is a Red Hat developed open source project. We're going to show Flannel as a CNI. We are going to show Spiffy as the identity for the pods in Kubernetes. We're also going to show Gateway API. So let's go ahead and get started. All right, may the demo gods with me. So. All right, this is the application I actually built myself just 2 weeks ago. So I built a very, very simple server, which all of you should understand what it is. By the way, is the font in the back? Can you guys see it in the back? All right, good. I want to take care of you guys in the back, but do let me know if it's too small. So this application is in JavaScript. As you can see, it's very, very simple. So basically, we're creating a server, right? And it's print out a message that says, hello, KCD Munich. And we're listening on port 3000. And that's about it, right? The simplest code you can ever write for a server. And I have a Docker file for this JavaScript. Basically, I package I expose on port 3000, and I call npm start to start the server. And also, I build a server.yaml file, which is Kubernetes, a Kubernetes service. How many of you deploy Kubernetes service before? I'd expect maybe most of you. All right, good job. And And we're going to put a version of the server, which is server version 1, and they are running on port 3000. Just keep it simple. The container port is 3000. The service is also port on 3000. And this is our simple deployment. So nothing fancy here. So basically, I already built to save the network bandwidth and time. I already pushed the image. It's called Linsun server simple. And I pushed to my Docker Hub. So we're going to pull down the image and start the server shortly. And I also have a simple Kür client. And the client is really simple. So all it does is spin up a Kür container where I can call Kür command and sleep there. So the container is ready whenever I want to call the Kür command. So it's using a standard image. So I didn't have to do any work for the client other than write the simple YAML file. So let's go ahead. So I'm going to jump into the simple folder. You guys can see in the back? Yes? All right, awesome. So what I'm going to do is I'm probably going to need your help because I don't like to script the demo, so I may have typos, so please just correct me if you see anything I did super wrong or I made a typo that's obvious. So we got our server deployed, right? And we're going to deploy our client. All right, I got it deployed. Remember we said we're going to use K9S, which is our UI, and as you can see, we're using K3S. We're using a 2-node cluster. Right now, you are seeing my default namespace, right? So we got the server deployed, we got the client deployed. So let's do a simple Kür request. So what we're going to do is we're going to do kube exec. All right, if I can remember. So we're going to do, okay, I'm going to cheat a little bit here. It's frightening to remember on stage. So let's do this. Okay, I think, so I'm going to do, so basically I'm going to do this command here. So I'm going to do a copy paste. Sorry, I just had a frightened moment. I forgot the commands, but this is the command I was thinking to run. So basically, I'm going to exec into the Kür client and run the Kür command to say, I want to talk to server 3000. So what do you guys think is going to happen if everything works? All right, I'm going to show you guys. So think about it. All right, we got our hello message, hello KCD Munich. So what does this mean? This means server works. And this also means the server is serving HTTP traffic, right? The client is calling server plain text HTTP on server 3000. So now the next question is, how do we change this to do mutual TLS between client and server, right? What if your company security team come to tell you, this is not great. I don't want to see plain text among the application within the Kubernetes cluster because I'm running a multi-node Kubernetes cluster. I want to secure the communication with mutual TLS. So the next thing we're going to do is we're going to work together on changing this application to mutual TLS. So I'm going to close this out. I have another folder. I want to show you the code. So this time, we're going to generate a bunch of key inserts. Remember, we talked about passport, right? So for application to run in Kubernetes, to have the right identity, they need to have key inserts. So in order to generate the key inserts, first I want to show you how I generated it. So basically, I use self-signed keys and certs. So the first thing I did is I used OpenSSL to generate the key for the server. And when I generate it, I specify, what RSI I want to use. And after I generate the server key file, I also use OpenSSL to generate a certificate signing request for the server. And you can view the certificate signing request easily using also OpenSSL command. So this is a certificate signing request. Sorry, I scroll up back too far. So you can see it's certificate signing request. And I made it with my organization, my location, and the CN is mutual TLS server. By the way, this is important because I'm going to deploy the server with this host name. So sometimes for certificate checking, it's important to have the host name match the CN. So basically, this is the certificate signing request. And after I have the certificate signing request, I can start to ask OpenSSL to say, hey, go ahead, give me a public cert using the certificate signing request. And with this public certificate signing request, I'm saying, I don't want the certificate expire very soon, so let's make it 365 days. And please go ahead, sign this certificate using the key, the private key of the server, and print out the server certificate for me. So that's steps through the server certificate here. So the way to step through a server certificate is you can using step certificate command to inspect the certificate. All right, so this is our certificate. Remember before it said certificate signing request, and now it says certificate. And the issue is the same organization. I had it before with the same CN. And also, you can see it's valid from almost a year from today, a week ago today, because I requested this a week ago, and it has the public key information, the signature, so everything you expect as a certificate, right? So, okay, so this is on the server side. Similarly, I have to do the same thing on the client side. Remember before I was able to use the Kerr client, some public image out there, but now because I want my client and server to talk through with mutual TLS, so I'm actually generating a bunch of certificate and key for the client side. I'm also copy the server's certificate to the client folder and the client certificate to the server folder because I want my application config them as a CA certs to use to validate the peer certificate in a mutual TLS configuration because I don't have a real CA and I have the self-signed certs. So let's walk through the server JavaScript application now. Not a lot of change after we successfully create the key and certs file. So basically, I'm changing this to be HTTPS now. Remember before the server was HTTP create server, right? So now I'm calling it HTTPS create server, and I'm passing a bunch of options now. So I'm passing my keys, my private key for the server. I'm passing my public certs. I'm also passing the CA using the client cert, so the server can use it to validate the peer certificate. And also, because I'm doing a mutual TLS connection, I'm telling the client, when you talk to me, I'm going to request your certificate, so I'm changing this to true. I also have a pass phase, which is hello. I'm also passing that into the option. All right, so now we got our server file updated after taking a major surgery along with the client. So what we're doing next is I want to show you quickly the Docker file. So the Docker file is basically, I want to make sure the files, the certificates are copied, and I want to make sure the application is started. Notice here, I'm actually also building a Docker file for my client. The reason is the current image doesn't have the certificate and the keys I need, so I'm actually copying it into a particular worker. All right, so I got my client and server image builds, so I'm going to deploy them. So this is my mutual TLS Kerr client. As you can see, I'm deploying, it's basically the same as the Kerr client, except I'm using the image for mutual TLS Kerr client. This is my mutual TLS server. It's basically pretty much the same, except I'm using the new images that can speak mutual TLS. So let's do it. So what we're going to do is we're going to deploy the mutual TLS server, and we're going to deploy also the mutual TLS Kerr client. And we're going to jump onto here and just make sure everything reaches running. All right, we did have everything reaches running, so you can see the mutual TLS server is running, and it's ready to accept the request. Now, we're hoping we should be able to call client from the server using mutual TLS, using HTTPS. So let's see if we can do that. So let's see if I can cheat a little bit. So what we're going to do is we're going to use the mutual TLS cur client, and we're going to call it HTTPS. And I'm going to specify my key, which is my client key, and the cert is my client certificate, and the CA cert is the server cert, which is used to validate the server certificate, and the password in this case, which is my name. So finger crossed it's going to work. All right, it's not working. Let me check to see what's going on here. Did I miss something? The server address is wrong? Okay, what is wrong here? Is it, oh, it's mutual TLS server, thank you. You guys are awesome, the best attendee. Do you think that looks right? All right, finger crossed. Yes! All right, it works. All right, thank you. So what I just showed, just to recap, to do mutual TLS the very hard way, I took a surgery on the client, I took a surgery on the server, and it actually did work, right? So this is pretty exciting. But I want to show you, is there an easy way to do mutual TLS, right? I mean, it's pretty painful, right? The certificate, what if the certificate expires in a month, right? I have to redeal the whole thing again. I have to rebuild my image. I have to push to Docker Hub. I have to recycle my, my deployments. So in my cluster, I also have Istio service mesh installed, and we have a new mode. Let me click on 0. So that's when you see everything else running in my cluster. So we have a new mode to allow you to do mutual TLS and traffic control and everything else, such as zero trust, without a sidecar. So I'm going to show you guys how to do that. So I'm going to switch back to the default namespace. And here, I'm going to, how many of you know how to label a namespace in Kubernetes? Everybody? Yes? Yes? All right. So what we're going to do is we're going to label the namespace default with istio.io data plane mode / ambient, which is the new mode without sidecar. All right, after I label it, I'm going to rerun this command, and hopefully it would work again. And hopefully I'm getting mutual TLS, so let's validate that. In the meanwhile, I'm just going to run a loop because I'm going to generate a bunch of traffic to see if we can see it in a dashboard. All right, so we got our traffic going. So how many of you use Prometheus today? Yes? All right, a lot of people, a lot of fans for Prometheus. All right, so I did deploy Prometheus also in the monitoring namespace. Just show you guys quickly here. So I mentioned earlier on I have Prometheus and Kayali in the monitoring namespace. And we're going to launch the Prometheus dashboard. All right, let me make this bigger. Sorry, I should have prepared this before my talk. All right, so so we're going to check TCP received bytes, which is one of the metrics we generate. And the destination app, remember we have two destinations. One is server, one is mutual TLS server. And now we want to see if the plain server can get mutual TLS. All right, looks like we have a bunch of data coming in. So as you can see, by simply label my namespace, I'm getting mutual TLS from my client curl client to my server without touching anything other than enable the namespace. As you can see, there's no restarting, there's no sidecar associated with my client and server, right? So we got metrics on premises. The other thing I want to show you is not only we got metrics, we also have a dashboard. I'm going to launch. So the reason I want to show Prometheus first is Prometheus is really, really powerful. With Prometheus, you can pretty much build any type of dashboard, right? So for instance, this open source project, Kayali, which is building the dashboard based on Prometheus. So as you can see, from my curl client to my simple server running on version 1, not only I have mutual TLS traffic going on, but also I have mutual TLS principal with SPIFFE ID assigned to the client and also assigned to the server. And I also have TCP metrics coming as part of the Prometheus traffic, metrics coming and on this dashboard. So that's the first demo I want to show. I have a few minutes. The second demo I want to show quickly, if I have enough time, is I want to kind of scale my deployment to the server deployment to 10. To 9, actually. Actually, I want to deploy the second version of my server. So I actually write 2 versions of my server. And the second version of the server is the same as the first one, except I changed to Hello KCD Munich 2024. So I'm not going to show you the code to save a little bit of time, but you got the idea. So and then I'm going to scale. I'm going to do traffic control because I'm deploying a new version of my second server, right? So I want to be able to do traffic control. So what's the hard way to do traffic control if I want to send 90% of traffic to version 1 and 10% traffic to version 2? Anybody? Okay, the hard way is just scale your pods, which I gave a hint early on, right? So basically, to do the hard way is I scale my server version 1 to 9, and my version 2 has only 1 pod. So that way, Kubernetes knows to send 90% of traffic to version 1 and 10% to version 2. So I'm going to have this running. So you can see it's about 90 and 10. So this is a little bit stupid, right? I mean, what if you do a better way? So what I'm going to do is I want to show you if there's an easy way. All right, let me go back to the prompt I have. So the easy way is I want to change the replica to 1 first. So I have both server and client 1. And then the next thing I want to do is I want to deploy an Envoy proxy to control my traffic. So what I'm going to do is I'm going to deploy a waypoint proxy. Actually, I'm going to try to see if I can. Okay, I'm going to apply a waypoint configuration, which is not in here. Let me see if I can find it. All right. So a waypoint configuration is a Kubernetes gateway resource. It essentially says I want to deploy a Istio waypoint, and I want to make sure you listen on HTTPS traffic on 15008. So with that, I'm going to deploy waypoint, and we are also going to deploy a label just to say for the default namespace, we're going to use this waypoint. All right, so this essentially will stand up a waypoint proxy deployment, and you see our deployment reaches running. Now, the last thing I want to do is I want to deploy a route for 90 and 10, well, I want to send version 1 to be 90 and version 2 to be 10. So with that, we're going to see traffic coming into changing quickly between 90 and 10. Well, before that, because I have equal pods number, so it's about 50-50. Now you can see with a symbol through Kubernetes gateway resource, which I'm going to show the resource here quickly. that I can simply change my traffic routing to not to be the stupid way, so that I can change a weight. So this is using the new gateway API, using the HTTP route. All right, I think actually I'm running out of time. I'm having so much fun talking to you all. And let me see if I have anything closing. All right, so the demo is still running. If you guys are interested in additional resource, I'm going to jump into one last thing. I want to say this is the house actually being built. Imagine how nice I was able to secure communication without Sidecar, and there's additional resources if you're interested to try. I did write a book about Istio Ambient without Sidecar, if you're interested in downloading that. With that, I'm going to open up for questions because I think I'm running out of time. Am I right? All right, I'm going to ask you all do one thing. If you really enjoy my talk, do you mind if I take a selfie? Because I travel a long way from US to here. I just want to tell my boss I did do a work and I did do a good job, hopefully. So I'm going to try to take a selfie. Raise your hand if you enjoyed it. All right, thank you so much. Now let's open up for questions. Anybody have any questions? All right, thank you for whoever raised up your hand. I hope it's not overwhelming. It's a lot of demos, so.
Yeah, so first, thanks for this very interesting talk. There's one thing I did not fully understand. In the Istio Ambient way of doing things, where does the certificate come from?
Oh, well, that's the certificate come from?
Is that the same certificate you generated before, or how is it referenced?
Yeah, that's a great question. I appreciate that question. So that's one thing I didn't have time to talk through. Okay, so remember I said there are 3 nodes in my cluster, right? So these client and server, and even the mutual TLS one, they're distributed onto different nodes because I don't have any scheduler affinity configuration. So if you look at everything running in my names, in my cluster, I have Istio CNI and also the Zero Trust Tunnel, which is Z Tunnel, deployed also as a daemon set on every single node. So basically, when the traffic comes, when the pods are scheduled on the node, the co-located Zero Trust Tunnel is going to be talking to Istio control plane, and the Istio control plane, in this case, is a CA. So if you guys are familiar with how Sidecar works, that's exactly how it works, except that right now we're running proxy for layer 4 function per node. The layer 7 function is the waypoint proxy, which you can run it per namespace. So it's like a sidecar, but it's not a sidecar because you're running outside of your application and you can configure the scope of it. So to answer your question, Istio is a certificate authority as a control plane, and then the Zero Trust Tunnel communicate to the Istio and ask, hey, this is the particular service account for this pod. Can you mint the certificate for it? And you can also plug in, that also allow you to plug in like your additional CA if you want to. Does that answer your question?
Absolutely, thank you.
Yeah, great question though, thank you. By the way, the certificate I didn't have a chance to show you, it expires after 24 hours, so that you know, it's kind of a better secure. It's kind of like instead of a whole 365 days, yeah. So we automatically rotate the certificate for you without you needing to do anything. I think somebody has a question here.
Thank you. Many of us were actually looking forward to the ambient mode. Recently, Istio finally very deservingly went into GA mode, and so no longer so many beta APIs, but I still saw you had 2 resources in beta mode. When can we expect them to go GA?
Yeah, that's a good question. So we recently launched beta for Istio Ambient. We are hoping to go to GA later this year. In fact, we actually have user already running in production. So this is one of our users. As soon as they went to beta, they started running in production, and they gave us this quote of how ambient significantly simplify management and also reduce their entire Kubernetes cluster, not just the service mesh, by 20%, which is huge, right? So they were a sidecar user of us, and they switched to ambient for the cost of saving for them. Yeah, so this is the best time actually give us a feedback, because we don't want to go GA and find out it doesn't serve your purpose. We do expect to promote ambient to GA later this year.
Thank you.
All right, good question, same question. Oh, there's another question here from this gentleman.
Thank you very much for your talk. I'd be interested in the waypoint server, because normally one of the features of Gateway API is traffic splitting, but you need an additional waypoint server. And could you run this with multiple replicas, which you probably need to do to make sure it's not a single point of failure?
Yes, so the question is, can you run multiple replicas with the waypoint? Yes, the answer is yes. The Gateway API is extensive enough, so you can attach your auto-scaling policy with the waypoint, along with through like policy attachment through your gateway resource. So that would ensure your waypoint can automatically scale out and in. Does that answer your question?
Yes, partly. I was kind of interested.
I may only heard part of your question because there was some clock.
I was also interested. So it's essential that you need this additional pod, the waypoint service, to actually do the traffic splitting in your use case.
Okay, that's a great question. So there is a reason why we don't put layer 7 per node. So so first of all, Envoy was not designed for multi-tenancy. So we spoke to the founder of Envoy, which is Matt Klein, and Envoy was not designed for multi-tenancy, and he believed complexity was not worth the risk. So secondly, we do believe Envoy, so if we think about Envoy being single tenant, so you don't want a shared Envoy proxy bring down the entire node, which includes applications maybe serving like different tenants, right? So the layer 4 proxy is super lightweight. That's why we feel comfortable to be sharing. So you do have to stand up your waypoint. But what's really nice is you can configure the scope of your waypoint. You can have waypoint per namespace. You can, in the future, we're going to add waypoint for multiple namespaces, if that's a scope you feel comfortable, or you can scope down to say, I have waypoint per service account.
Thank you very much.
Thanks. All right, thank you so much. Thanks, everyone. Really appreciate your time.